Hey, good morning, everybody. And we're going to get into your homework here on section 2 in chapter 9 and just talk a little bit about how to find the area of non-right triangles, okay, using a non-standard formula. So again, this is for any triangle, but typically you use it for non-right triangles, angles that are not right triangles, okay? Ones that do not have a 90-degree angle involved. So basically, it goes like this. The area of a triangle is going to be 1/2 times side 1, okay, side 1 times side 2, all right, times the sine of the included angle, okay? So we have to talk about what it means to be the included angle, okay? So side 1 and side 2 are adjacent, and the included angle is between the two sides. So a little note here, that the sides are adjacent, okay? That means they have a common vertex. All right, so they're adjacent. Number one, that's point number one. Point number two is that the included angle is between the two given sides. So angle must be between, all right, the two given sides. And if you have this situation, namely called a side angle side situation, side angle side, a side and then an angle and then a side, you may use this formula, okay? 1/2 times the side 1 times side 2 times the sine, which is a function of the included angle. It has to be a side angle side situation though. All right, so let's get right into it here. So the area of this one is going to be 1/2 or 0.5 times side 1, which is 7.4 times feet, that is, okay, times 8, all right, times the sine of the included angle, 143 degrees. And then you're going to approximate it to the nearest tenth. Okay, so what's the area? So let's go right into it here. Let's grab Desmos Scientific Calculator here. Now 1/2 is the same as 0.5, so you can enter in 0.5 or you can go 1 divided by 2, whatever your preference. All right, times the first side, which is 7.4 feet, so 7.4, times the second side, which is 8 feet, times the sine of the included angle, which happens to be 143 degrees. And when you get an answer here, you add it to the nearest tenth, and that's about 17.8 square feet. So this one's about 17.8 feet times feet is square feet. I always square units for the area. All right. Feet times feet, all right, gives you square feet. Square units. So if you have a side angle side condition, all right, then you may use this formula at any time. It's the easiest thing in the world, actually. It's a calculator problem. So on this one here, number 2, it's 1/2 times the first side, 10 inches. All right, times the second side, 14 inches, times the sine of the included angle, 71 degrees. All right, make sure you show your setup, by the way, because that tells me that you're actually doing this correctly and you know what you're doing. All right, so let's figure that out. So 0.5, it's easier for me to enter as 0.5 times 10 times 14, all right, times the sine of the included angle, 71 degrees. And you get about 66.2. Okay, square inches in this case. So 66.2 square inches. Very simple. Whenever you have a side angle side condition, this formula is used, especially when you're not dealing with right triangles. So you have a side angle side condition here. So it's 1/2 times this 16 yards times 5 yards times the sine of the included angle, 70 degrees. So the area is approximated by this formula here. All right, so let's type it in. So we got 0.5 times 5 times 16, so 5 times 16 times the sine of the included angle between the two sides, and we get about 37.6 square yards. So 37.6 square yards. And that's all there is to it. All right, so number 4, 1/2 times 13 meters times 9.7 meters times the sine of the included angle, 95 degrees. And what would the area be in that case? So I don't know, let's figure it out. So we got 1/2 for 0.5 times 13 meters, so times 13 times 9.7. all right, times the sine of the included angle, 95 degrees in this case. And you get about 62.8 square meters in this case. So 62.8 square meters, okay? Meter times a meter is a square meter. So remember that units are important. The square meters are generated because when you take a meter times a meter, you get a square meter. Area is always measured in square units, as you guys know. Okay, again, side angle side condition. So the area is 1/2 times 10 meters times 14 meters. All right, times the sine of the included angle, 27 degrees. And the area is approximated by, let's go ahead and multiply here. So 0.5 times 14 times 10, or 140, so times 140, I just did that in my head, times the sine of 27 degrees. All right, and then you just approximate it and round it, so 31.8. So there we go, so 31.8 square meters. Easy. Easy peasy lemon squeezy, okay, as they say. So 1/2 times 7 meters times 15 meters times the sine of 27 degrees for number 6, the last one. So let's work that out. So 0.5 times 7 times 15, oops, so times 7 times 15 times the sine of the angle, which is 27 degrees. And you get roughly 23.8 square meters. So 23.8 square meters. So it's a side angle side condition. So one more time, the main idea, and it's easy to remember, is 1/2 times side 1 times side 2 times the sine of the included angle. And remember the two important things: sides must be adjacent, the angles must be between the two given sides, or it must be a side angle side condition. Okay? And that's all there is to it. I'll see you in my next lesson. This is Ainsworth. I'm out of here. Bye-bye.